Welcome to this video, where I'll add some basic keyboard movement to a simple JavaScript game, step by step. In the last video, part 1, we set the foundations of this project, defining our objectives, and they haven't changed much. We're making a dungeon using a framework called W, and although I'll probably keep calling this a game, we're really just making a skeleton of a game. The only new goal I added was to keep things small. I want to keep the overall code size pretty micro, in hopes that some of it could be used for future JavaScript 13K game jams. Last time we got a basic maze-like dungeon to render to the screen, so we'll be using that for our start. As a reminder, all the code is open source on GitHub, so you can follow along there. And if you find this project interesting, please like and subscribe. Before we get started coding, let's swap out our local server for Vite. Vite is a modern set of tools with a lot of features, but the one that we actually care about is the ability to automatically reload when we make a change. You may have noticed that before I was constantly reloading the page after every change, and that gets tiresome, so Vite will basically do this for us. Next, we want to move some of our character functionality into its own class. We do a quick test and make sure everything's working still. Let's just clean up our code a tiny bit by moving everything that renders into a function called render. Now let's finally get to the movement. Handling keyboard commands in JavaScript is something I've done a million times before. I put together a nice library for this called Keyboard Commander. Because we want to keep this particular project micro though, we won't bring this in as a dependency, but otherwise you might want to consider either using this or copying parts of it. In JavaScript, you want to listen for either a key press or key up event, and then run some code. For our purposes, we'll just look for key up. To start, we'll just check to see if the up and down arrow keys are pressed or the W or S keys. And there we go. The character sphere is moving up and down as I press the up and down arrow keys. Now that we can move forward and backwards, in order to get proper dungeon movement, we have to keep track of which way the character is facing. We'll do this by setting a value for each of the 4 cardinal directions, and then creating a turn method that will switch between them. We'll look for when the left and right arrow keys are pressed or the A and D arrow keys are pressed, and then do the turn. Then we have to change the forward function so that it moves the character based on the direction that they're facing. And there we go. Now it's working. Left and right turn us, and up moves us forward. Next, we're going to add a layer of abstraction between the keys that are pressed and the actions that are taken. This will allow us to easily remap the keys to different actions if we'd like. There are some dungeon crawler players who prefer to turn with A and D, and then there's some who prefer to turn with Q and E. We'll start with just two commands that can be given, turn or move, but then additional parameters for the direction of the movement or the turn. Let's make our turn function a little more flexible so that I can take in a string for the direction. I get distracted for a moment thinking that there's a bug in the turn code or the movement code, but it really ends up just being that I forgot to render after the action is taken. Okay, now the changes seem to be working correctly. So far the character has been moving around, but the camera's been locked in place, just looking at the maze. In most games, the camera will follow the character wherever they go. It's easy enough to set the camera's XY coordinates to match the character's XY coordinates. But we have to remember that the XY coordinates of the character are really the position in the dungeon map, but the coordinates that we're actually rendering to are the position in the world. And because the blocks are not 1 by 1, they're actually 2 by 2 right now, those coordinates will be different. But after a little bit of fiddling around, we finally get it to work. As something left over from the previous video, we were changing the block colors every time we rendered them. But this won't do. We'd rather just render over and over and have the block colors be consistent. So let's make some changes. I realize I'm going to want some reusable random functions. So I look up a library that I've used before called Little.js. This is done by another minification expert who goes by the name of Frank Force. The framework is designed mainly for 2D games, but it has a ton of really great micro functions in it. Now we have a nice function for getting the random color, but I kind of go back and forth on how I want to actually format the code here. Eventually I settle on taking an input of an array of ranges, and each range is an array itself with the min and max values that will generate randomly between. So we've accomplished everything we wanted to in this video. We have some basic movement by keyboard commands, and the maze, even though it's just temporary, has consistent colors now and doesn't hurt your eyes. While working through this, I did get distracted by trying to get animation to work. I ran into a bunch of errors, couldn't quite figure it out, but then I had to remind myself that animation was only a wish list item on our goals. We'll have to tackle that in a future video if we have time. If you found this useful, please give the video a like. If you have some ideas for things to try out, go ahead and leave a comment below. Next time we'll see if we can finally switch to a first-person view. Should be fun. See you around.